All right, my wonderful grade 8 students, thanks for tuning in here on Friday. I know you guys are probably going stir crazy because there's only so many TikTok videos one can make and only so many games of Minecraft you can play. And you're probably missing your friends and your teachers and your routine of being in school. So we're making the best of it, and we have a 9fer that we assigned on Wednesday. You had 3 days to work on it, and it's not that hard. It's actually all questions you've been doing before. Some of you might have forgotten how to do it, so this video is just for you. So go over your work, have your sheet in front of you that you have your answers on. And if you didn't do your work yet, just press pause, try the questions right now, and then I'll reveal the answers after you're done. You can just press unpause. So our first question says 3/4 plus 1.5. This is the grade 7 question where we add a regular fraction plus a mixed fraction. And there are various ways to do it. You can gather your whole numbers up first and then gather up your fraction parts and add them all together at the end. But I think we all agreed that the easiest way is to have one standard way to solve it. And that way to do it is to simply think of all mixed fractions as improper, because the algorithm for solving it is going to be consistent no matter if it's going to be borrowing or no borrowing. It's a subtraction. So we found this way to be the easiest. Once you have it that way, you need common denominators when adding and subtracting. Equivalent fraction, of course, we know that we multiplied both by 3 to create equivalency. Sorry, no, we didn't. You're lying, Mr. McDonald. You multiplied it by 2. Because 2 times 2 is 4. And therefore, 3 times 2 is 6. So the equivalent fraction to 1.5 is 6/4, which is still 1.5. Once we get that, add your numerators and keep your denominator. Your answer as an improper fraction is 9/4. And as a mixed fraction, it's 2.25. In your second question, you have a multiplication of 3/4 times that exact same fraction. Instead of adding, we're going to multiply these two. The process is similar in that we first change all of our mixed fractions into improper because it makes it much easier to do. Once we have that, our algorithm in grade 8 is much easier than grade 7. We simply multiply our numerators and multiply our denominators. Our answer is 9/8, which is 1 and an eighth. Now, what I want to kind of draw your attention to real quick, this is just an aside, is when I added them, I got 2.5, and when I multiplied them, I got 1 1/8. I got a smaller number when I multiplied them than I did with adding. So this is an interesting one. So 3/4 plus 1.5 is greater than 3/4 times 1.5. And I just want to just touch on why this is true. Because normally in elementary school, you learn that multiplying makes numbers bigger than adding, usually, right? When we multiply two numbers together, it becomes bigger than when adding. But in this case, it's not true. And why that is because we only have 3/4 of 1.5, right? If we translate to what that multiplication statement actually means, 3/4 times 1.5 is just 3/4 of 1.5. So we know from this statement right here that my answer has to be less than 1.5 because we're not taking all of 1.5. We're taking only 3/4 of 1.5, and we did that. 3/4 of 1.5 worked out to be 1/8. Whereas over here, we know that our answer is going to be bigger than 1.5 because we're adding something to it, not taking a fraction of that amount. So just think about that for a second, give that some thought, and realize that multiplying two numbers together doesn't always make it bigger than adding two numbers together. Our third question is -4 plus 6 times 5, which is really a grade 7 integer question. It's a bedmass question. We have more than one operation. We have addition and multiplication. I think by now you probably realize, perfect, that you have to do your multiplication first. So -4 plus whatever the product of 6 and 5 is, which is 30. So -4 plus 30, we're adding a negative and a positive together. We have more positives. How many more? We have 26 more, so our answer is positive 26. Our next question is also a bedmass of integers. It has written like this. And what this says is, remember, when you have no operation sign between a number and a bracket, multiplication is always assumed. That says 10 multiplied by -2 plus 3 multiplied by +7. So in effect, we have 1, 2, 3 operations here. 2 of them are multiplication. 1 of them is addition. The multiplication will become -20. The multiplication will become 21. positive 21. I'm going to even keep that in brackets as positive 21, just to make my next step a little bit easier. Because the last thing I'm going to do is add those together. I have negative 20 and I have positive 21. I have more positives. How many more? I just have one more positive than negative. So my answer is 1. Our next question is a reach back to grade 7 when we talked about fractions, decimals, and percent. So you gave 1/5 as a fraction. Now there are multiple ways to change it to a decimal. The easiest way is to simply take your calculator, which is right here. Oh, it's too big. Hang on a second. There, that's kind of better. And if you have 1/5, I'm just going to bring it over here now. Hang on a second. So 1/5 can actually be interpreted as to 1 divided by 5. 1 divided by 5 if I wanted to change it to a decimal. So if I go 1 divided by 5, I get 0.2 as my decimal form. Now that's one way to do it, right? The other way to do it is to think of equivalent fractions that have base 10 denominators. Since our decimal system, we have tenths, a hundredths, a thousandths, a 10,000ths. All of our place values are base 10 denominators. They're fractions that have a base 10 number as a denominator. So 1/5 is equivalent to 2/10. I know my equivalent fractions back in grade 5 and 6. You learn how to do this. And since I read this as being 2, so it's read as 2/10, which is written as 0.2, right? So that's another way to do it. You can actually think of it as equivalent fractions as base 10 denominators, and you can usually just read it and write it as a decimal. Most prefer the division 1 divided by 5 to change to a decimal. But once we have 2/10, we know that as a fraction, 2/10 is 2 over 10. And since percentages are fractions over 100, our equivalent fraction is 20 over 100, and therefore as a percent, it would be 20%. Right? So the idea of changing a decimal to a percent is to think of the decimal as a fraction and to think of that fraction as an equivalent fraction over 100. Another way to do it is just to convert it into 2 decimal places, because we know that with 2 decimal places, those are hundredths, that's tenths, hundredths, and this as a decimal is actually the same thing, 20 hundredths, and therefore you can think of it as 20% as well. You can do that as well, but both work. Our second line says 0.04, which if you read it using place value is 4 hundredths. And therefore 4 hundredths as a fraction is 4 over 100. Now some of you were probably pretty slick and said, you know what, I know that I'm not supposed to keep fractions not in the lowest terms, so if I reduce this to lowest terms, you divide both by 5 and I got 1/25. Or some of you might have had 2/50ths, but 2/50ths isn't lowest terms. So as a fraction, 4 over 100, or in lowest terms, 1 over 25. And the best one, of course, to keep would be this one, because 4 over 100 is really easy to convert to a percent because it's already a fraction over 100, and therefore it's 4%. And our last one says 15%. So as a fraction, 15% is real easy to do. It's 15 over 100. And again, some of you are like, I know that's not lowest terms. You can divide both by 5. Right, both are divisible by 5 because they end in 0 and 5. You get 3 over 20 as a fraction in lowest terms. And finally, as a decimal, this says 15 hundredths, 15 hundredths as a fraction. So 15 hundredths is 0.15, 15 hundredths. Our next 3 questions are all algebra questions. The first one says negative 2x minus 2 equals 6. And this should be the freshest in your brain because you had a test just before Christmas break on it. We have a coefficient of negative 2. We have a constant of negative 2 as well. We know that when we are isolating variables in 2-step algebraic equations, first thing you should probably get rid of first is your constant. We're going to do that by adding opposite operations to both sides. So adding 2 and subtracting 2 are opposite operations. I get negative 2x equals 8. And that says negative 2 multiplied by the value of x is equal to 8. So we're going to divide both sides by negative 2. That's the opposite operation of multiplication. And our value, or final value for x, is negative 4. Now if I go back into my question and substitute the x for negative 4, this should equal 6. And negative 2 times negative 4 is 8. And 8 minus 2 is 6. So therefore the value of x is negative 4. Our next question, x over -4 minus 2 equals -1. Again, we have a two-step algebraic equation with a constant and a fractional coefficient. Remember what we talked about before, a -1/4 of x. A -1/4 of x minus 2 equals -1. This equation right here is the exact same thing as that equation. And if you see it, great. If you don't, it's not a huge thing because you do deal with it more in grade 9 than you do in grade 8. But I like to mention it to people so that they understand that there is fractions and decimals are the same thing, just like when we did these questions over here. Fractions and decimals can be the same thing. So it's important you see it in algebra as well. Opposite operation, get rid of your constant first. We're going to add 2 to both sides. A -1/4 of x is equal to 1. We're going to multiply both sides by -4. And x equals -4. Go back in and check your answer. If you were to change this to -4, right, x is -4, then this would become 1. And 1 take away 2 is -1. Our last algebra question is distributive property, which is a new idea in grade 8. It says 3 groups of x minus 5 is equal to -21. Two ways you could solve it. You can say if I have 3 groups of x minus 5, that means I have 3 x's, and I have 3 -5's, which is 3 x's, and 3 -5's would be -15. So when I expand it using distributive property, that's what I would get. Now I have a grade, well, it's a grade 8 question. I'm going to add 15 to both sides. 3x equals 5 and 6, so it's -6. Divide both sides by 3, and x will equal -2. So that's solving that question with expansion. The other way you could have done it is said, well, I know Mr. McDonald has said 1,000 times that 3 groups of x minus 5 equals -21. So if I divide both sides by 3, instead of knowing what 3 groups of x minus 5 is equal to, I'm going to know what 1 group of x minus 5 equals. And 1 group of x minus 5 would be therefore equal to -7, because if 3 groups are equal to -21, each group of x minus 5 must be equal to -7. Add 5 to both sides, and x equals -2, just like I got before. And our last question says, what is an expression that represents 4 apples and 2 dozen apples? Not the answer, just the expression. So if I put 4 apples, I'm just going to draw it here. 4 apples and 2 dozen apples. This picture right here would represent 4 apples and 2 dozen apples. So the way we want to put it is the 4 apples and is always addition. 2 dozen apples is 2 groups of 12. So when we think about what is the expression that represents 4 apples and 2 dozen apples, this is the answer I was looking for. Or you could have put 4 plus 2 times 12. That works as well. But either way, that is the expression. And if you wanted to solve it, you would say it's 4 plus 24 apples, and that's 28 apples altogether. That's kind of a great example of why BEDMAS is used, because if you ignored BEDMAS and you added those first 2, you would have got 6. And 6 times 12 is 72. And we know that if I had 4 apples and 2 dozen apples, I don't have 72 apples. I have 28 apples. So it's a very good illustration of why we have to use order of operations. All right, that's it. That's all you had to do. Thank you very much for tuning in. On Monday, I'll give you a new assignment. Hopefully we're not learning at home, and hopefully we're back in person. And if we are online, Monday I'll have a new assignment for you. And good luck and stay safe. And as Santa Claus once famously said, be good to yourself and be good to each other.